Welcome children, welcome to the Prasad Techno School online classes, and today in this online classes we are going to teach you number system of standard 9, and this is our first video, and we will be giving some fundamental topics today, and if you keep watching the subsequent videos you will be completely understanding the number system concept of standard 9 mathematics. So let's have a look on this number system. The numbers that we are using so far are segregated in different branches. For example, total numbers that we are using are segregated as some are real numbers, some are imaginary numbers. And for the real numbers, we have two types. One is rational and irrational numbers. Under rationals, you have integers, and under integers, you have whole numbers, and finally natural numbers. So let's start the hierarchy from bottom to top. Let me say what is a natural number. Generally, our counting number that starts from 1, 2, 3, 4, 5, 6, they are our natural numbers. And from natural number, this is 1, 2, 3, and so on. They are our natural numbers. And one step more from natural number to whole numbers. Whole number starts from 0. So whole numbers 0, 1, 2, 3, and so on. And whenever you go to integers, you will have both positive numbers and negative numbers, that is 1, 2, 3, 4, 5 and so on, 0 and -1, -2, -3, -4. This is better we can able to represent on a number line. So let me draw a number line. Say this is a number line. I will be marking here 0 the number. To the right hand side of 0 I will be keeping the numbers 1, 2, 3, 4 and so on. And to the left of 0, I am keeping numbers -1, -2, -3, -4 and so on. This line is called a number line. So in this number line, if you start counting the numbers from 1, 2, 3, 4, these are all comes our natural numbers. 1, 2, 3, 4 numbers are called natural numbers. And if you start counting from 0, 1, 2, 3, 4, 5, 6, then these are called our whole numbers. But whenever you go to natural numbers, the natural numbers are to the right hand side of the number line as well as to the left hand side. Taking 0 as the reference, as you know right side, that is called your positive integers, and to the left hand side they are called negative integers. You have infinity number of positive as well as the negative integers. So if you consider natural number as a letter, then whole number will be its envelope, and similarly if a whole number is a letter, then integer will be its envelope. Similarly integers that comes under rational numbers. So coming to rational numbers, what is the difference between integer and rational numbers? Say for example, this is number line. On this number line, after 0 the next integer is 1, the next integer is 2, next 3, 4 like that. Similarly as you know left 0 and the next one -1, the previous one -2, -3, so on. But in fact, between 0 and 1, there lies infinity numbers. There lies infinity numbers, and all these numbers also there in our rational numbers. So rational numbers are all these numbers, including 0 and 1, all the numbers that exist between 0 and 1, or 1 and 2, or 2 and 3, and so on. To take this one as an example, let's consider a person is walking and another person is cycling. If a person is cycling and a person is walking, the moment he walks, he puts his step at one point, and the next he puts his step at 2, 1, and then he put at 2, 3, 4 like that. But he never keep scrolling his leg on the ground. So he is touching only this part of the road and this part of the road, this part of the road, and so on. Whereas another person, if he is cycling, he will be touching the total road. So you can say that this is belong to your rational numbers, but the person who is walking, he is touching only specific points on the road, that is like our integers. So rational numbers are more than integer numbers. Integers are only 0, 1, 2, 3, whereas rational numbers are all the numbers between 0 and 1, 1 and 2, 2 and 3, and so on. All the numbers are there. And now let's come to irrational numbers. one spot. So we will focus today more on what is rational numbers. Actually, in this number line, you have natural numbers, you have whole numbers, you have integers, of course you have rational numbers even. But our present topic is today to focus on the rational numbers. Generally, the rational number said that a number is said to be rational if it can be represented in the form of p by q, where p and q are both integers and q is not equals to 0. I mean to say that any number which can be represented in the form of a fraction, that is a rational number. For example, I will write a number 5. It is of course natural number, whole number, integer and rational. Why it is rational? Because 5 can be represented in the form of a fraction. You can write 5 as 5 divided 1. And some other number say 2.3. 2.3, this is also a rational number. Why? Because 2.3, 2 decimal 3 can be represented in the form of 23 by 10. And we can even keep root over of 4. The value of root over of 4 is either plus 2 or minus 2. And plus 2 can be written in the form of 2 by 1. And minus 2 can also be written in the form of minus 2 by 1. So, this number is a rational number, this number is a rational number, even these numbers are also rational numbers. So, rational number is a number which can be represented in the form of a fraction where the numerator is belonging to natural number and denominator also belonging to natural number except 0. So, here 23 or 5 or here 2 and 2. 23 is present in this number line and 5 also present in this number line, and similarly plus 2 is there and minus 2 there. All the numerators are belonging to your number line, and similarly the denominator 1, 10, 1 they are also belonging. So let's write me one more fraction. Say for example the fraction is 6 by 0. 6 by 0. The numerator 6 belongs to number line, 0 also belongs to number line, but as per the definition of rational numbers, the numerator should be an integer, any integer of the number line, but denominator should be any integer except 0. Since that denominator is 0, it is not a rational number. So children, you have to recognize what is a rational number. Rational number is the number which can be represented in the form of a fraction. The numerator is an integer, denominator also an integer except 0. That is called your rational number. One more example to check whether the given number is rational or not. I will write the number 3.3. It is rational. Of course, you can write this one as 33 divided by 10. Second example, 3.33. This is also rational number. Why? Because you can able to represent 3.33 in the form of fraction, that is 333 by 100. And now the third example, 3.333. This can be represented as 3333 by 1000. So you could able to represent 3 decimal 3, 3 decimal 33 and 3 decimal 333 in the form of fraction. So this is a rational number, this is a rational number, and also 3 decimal 333 is a decimal number. But take the case 3 decimal 3333 and it continues. It continues for infinity. If the number is 3 decimal 33333 like this, whether it is rational or irrational, sometimes you will be confused. And to say accurately, before you are going to judge that whether it is rational or irrational, let's have a small example. For example, you are dividing 10 divided by 3. If you are dividing 10 by 3, let's see what is the value. 3 3s are 9 and 1 is the remainder. Place in the decimal. Once again you get 0 and 3 decimal. Again 3 3s are 9, 1 and decimal 0 and 3 3s are 9, and this continues forever. So 10 divided by 3. 10 divided by 3 results as 3 decimal 33333. Whenever this example is given, 3 decimal 3, you can able to do 33 by 10, that is a rational number. 3 decimal 33, 333 by 100, otherwise 3.333, that is 3333 by 1000. You will say that these are all rational numbers. But when the question comes to you 3.3333 and so on, you say it is irrational. But really it is not irrational. This is also rational. Why? Because as per the definition of rational numbers, if any number is represented in the form of fraction, provided the numerator is integer and the denominator is integer, it is a rational number. So 3.333 so on, it can be represented as 10 divided by 3. 10 divided by 3. Hence, this is also your rational number. Stop this. Coming to rational numbers, 5 is rational number because 5 can be represented in the form of 5 by 1. Both numerator and denominators are integers and denominator not belonging to, it is not 0. 2.3, that is 23 by 10, and even 3.3 bar is 10 divided by 3. So if this, then what is irrational? You might be confused that what is irrational. All the numbers are here itself. Natural numbers, whole numbers, integers and rational, all the numbers are coming here. What is irrational number? Let me write one decimal expansion: 3.31, 32, 33, 34 and so on. This is an irrational number. Why? Because although the decimal part is non-terminating, at the same time it is not recurring. So even the fixed decimal points, you will have rational number. Even if it is recurring, that is also you can convert in the form of fraction. But any decimal part, suppose non-terminating as well as non-recurring, here 31, 32, 30, nothing is repeating again and again, so that will be irrational number. And one more example of irrational number is root 2 and root 3 and root 5, these numbers, because if you want to find out these values, then you will find a non-terminating decimal, at the same time non-recurring decimals, so they comes to your irrational numbers. And let us come to real numbers and imaginary numbers. All the numbers, rationals, irrationals, integers, whole numbers and natural numbers, they comes under your real number. Then what is imaginary number? Imaginary number, for example, if you are going to find the square root of 25, you will get two results, that is one is plus 5, the other one is minus 5. But if it is the case of 25, square root of 25, you cannot able to find its value. And these numbers are called your imaginary numbers. In the higher classes you will be learning that is 25 into minus 1, and minus 1 is written in the form of I square, so that square root of 25i will be 5i. This will be taught to you in the college level. And that's all for this video. Keep watching our classes to have your subsequent classes. Thank you all.